Today on How It's Made. Space pens. Reef aquariums. Metal caskets. And composite bicycle wheels. The space pen can write in zero gravity, which is why astronauts have used it. It also writes underwater, in extreme heat or cold, or when held upside down. All this is possible due to the pen's ingenious design that keeps ink flowing toward the tip no matter what. The space pen's ink is pressurized with nitrogen, so unlike ordinary ballpoints, it doesn't rely on gravity to flow toward the tip. Invented in 1966, the pen first went into space with the Apollo 7 astronauts. The pen's writing point starts out as a 3/10 of an inch long block of stainless steel. It passes through more than a dozen machining operations that progressively shape a point, then bore a hole through the tip to form a pocket for the carbide steel ball. That makes this a ballpoint. The last station inserts the ball and curves the edges of the pocket inward so that the ball is locked in, yet can rotate to spread ink. The replaceable ink cartridge, called the refill, begins as an empty brass tube. This assembly machine inserts a white plastic ball into the back end, then pumps in half a gram of ink. The white ball is called the float. Its job is to follow the ink down the tube, moving residual ink forward toward the point. Next, the machine inserts the writing point into the opposite end of the tube. Then it crimps the end to ensure the writing point can't dislodge. Back to the other end of the tube now, the machine applies a bit of sealant, injects nitrogen to pressurize the refill, then caps the tube with a hollow brass plug. Nitrogen is ideal for pressurizing because it's an inert gas that doesn't harm the refill tube or its contents. This demonstration shows how the pressurized nitrogen forces the ink flow. After subjecting each and every refill to a writing test and washing the surface to remove traces of machine lubricant and other residues, a printer applies the company name and product information on the refill. Certain space pen models have a cap that fits over the writing point. A feeder places a brass cap on each spoke of the cap assembly machine, which then pushes the cap into position to receive a clip. The clip is stamped out of spring steel, a fairly flexible metal. It's chrome-plated for corrosion resistance and aesthetics. The machine drives the clip's teeth through the wall of the cap, then curls them back toward the inside of the wall, locking the clip in position. To prepare the two-part brass body of the pen, a feeder drops the bottom part, called the barrel, onto each spoke of the barrel assembly machine. To straighten the writing end, the machine inserts a brass reinforcement piece called the nose tip. It then crimps the end, flaring the nose tip inside the barrel so that it becomes wider than the barrel opening and therefore can't slip out. This model has a chrome-plated brass body and clipless cap. To begin assembling the pen, workers place the barrel in a foam holder, insert a spring to keep the refill in position, then a threaded connector made of brass. The barrel goes through a machine which puts a silicone rubber O-ring on the top edge of the barrel. And now the final assembly. They place a refill in the barrel, insert the connector into the top half of the body, then, with an electric motor, thread the parts together. After placing the cap open side up in a foam holder, they insert the pen. The O-ring holds the cap in place. The original space pen, still in production, has a push button on top to push out the refill and another on the side to retract it. This demonstration pen has a cutaway section to show the inner workings. All space pen models can write underwater and in zero gravity. They also work in freezing cold, intense heat, and upside down. A reef aquarium takes underwater exploration to a whole new sea level. It's a mini coral reef system recreated in a glass tank. Installed in a home or business, a reef aquarium allows people to see life on the bottom of the sea without donning a wetsuit and a snorkel. A reef aquarium is a living, breathing, and growing ecosystem. Along with tropical fish, it has spectacular coral and more low-profile organisms like crab, shrimp, and tiny aquatic creatures. All these organisms act as a biological filtration system for the water in the tank. They supplement the biological filtration system with mechanical and chemical ones. The assembler starts with a pump that recirculates the water. He installs it in a tank under the display tank. This tank is known as the sump. He places the protein skimmer in the sump beside the pump. This unit injects air bubbles into the water to remove organic compounds before they decompose and become waste. He adds a UV sterilizer. It has a high-intensity light that will be activated when needed to kill free-floating bacteria, parasites, and algae. Next, he introduces the media reactor. This cylindrical device contains both activated carbon and an aluminum-based media. These materials will absorb fish waste byproducts, thereby removing them from the water. With the mechanical and chemical filters in place, he now moves on to the display tank. He spreads real ocean sand on the bottom. This sand will be a habitat for some of the bacteria and other organisms that will aid in the biological filtering process. He selects rocks from a supply tank and transfers them to the aquarium. The rocks are home to numerous algae, bacteria, and small invertebrate. This makes them the central part of the aquarium's biological filtering system. He now prepares the ocean potion, adding synthetic sea salt to water. A pump circulates the water as the salt dissolves over a period of 24 hours. He presses a switch, and the premix of water and salt flows into the tank. This water now needs to mature. It will take weeks for tiny aquatic creatures to begin to thrive in this water. During this time, the filtering equipment in the pump below helps keep it clean. The protein skimmer foams up as the water constantly circulates through it. After about 3 weeks, there are enough microorganisms in the water. It's ready for coral and fish. These corals have been grown on an ocean farm and kept in this holding tank for this very moment. Each coral is composed of tiny, fragile animals called coral polyps. They are essentially little colonies. As the aquarium technician makes his selections, he considers how the coral will adapt to light and water motion, and how compatible the corals will be with one another. Some corals are very territorial and may release toxins when they come into contact with other corals. He leaves a lot of space between the corals to give them room to grow. Allowed to thrive, some will triple in size. He now introduces fish. Clearly, this aquarium has all the comforts of home. He installs a lighting system overhead that mimics ocean light at different times of day: sunrise, daytime, and sunset. For the creatures in this reef aquarium, light is a source of energy. With the Reef Aquarium now complete, the monitoring begins. He'll test the water chemistry regularly to ensure the right environment is being achieved. The activity of the fish and coral will be under observation to confirm this mini reef system is becoming a thriving marine community. Only then will this reef aquarium be ready to go public. So much more than a fish bowl, the Reef Aquarium brings the wonders of the ocean to the surface. A central part of arranging a loved one's funeral is choosing a casket. This is often an emotionally difficult decision, as it forces us to face the reality of the loss. Caskets are most commonly made of either wood or metal, and range in style from understated to ornate. There are two styles of caskets. Full couch models have an undivided top to show the deceased from head to toe. Perfection cut models have a split top to show the deceased only from the waist up. This factory makes metal caskets constructed from sheets of steel. To form the top, workers insert a sheet into a press. A die inside draws the metal into a paneled shape. This requires 900 tons of pulling force, the equivalent of hoisting 27 fully loaded tractor trailers. After trimming the edges, workers insert the panel into an automated folding machine. First, the machine bends both long sides upward, 2 bends of 90 degrees each. Second, it bends both short sides upward the same way. Then workers weld the corner seams. They also assemble and weld the casket's side, end, and reinforced bottom panels. These too were shaped in the press, but with a different type of die which stamps rather than draws the steel to the required shape. For a perfection cut casket, they saw the top in half. Then weld steel to the cut end, forming a header to give it a neatly finished look. An automated belt grinds all the welds flat to create a smooth finish. After a cleaning, all the parts travel through a booth, inside which 20 automated spray guns coat them in powder paint. An electrical charge draws the powder particles onto the steel, ensuring a thorough and even coat, which a giant oven then bakes for 20 minutes. Once the surface cools, workers inspect the paint finish to make sure it's flawless. Workers apply hot melt glue on the inside, along where the bottom and sides meet. This makes the body of the casket watertight, and they conduct a water test to make sure. The casket is lined with crepe, a synthetic fabric which is formable when you apply high heat. This specially designed machine heats the material with an iron, as serrated wheels gather into decorative pleats known as shirring. The high heat forms the fabric to this shape permanently. Sewers cut and sew the shirred fabric into lining components. Meanwhile, workers mount the casket's steel hardware, either stationary handles or swing bar handles which pivot. They place a rubber gasket around the top edge to ensure a proper seal when the top is closed. Then they mount the top. The gasket has holes for the steel hinges. By this point, they've already attached most of the interior fabric over an inner lining of corrugated cardboard. Now it's time to install the steel bed using an expandable rod. The bed's height is adjustable, enabling funeral directors to elevate the deceased for easier viewing. A mattress pad and sheet go on the top of the bed. Clips on each end hold them in place. A pillow completes the interior. Every casket undergoes a thorough final inspection. Then it's shipped to the funeral home that ordered it. The funeral home typically displays several sample pieces showing the range of styles, colors, hardware, and fabric options available for a loved one's casket. In the cycling world, carbon composite wheels are the wheels of change. They can weigh half the amount of traditional metal wheels, so the cyclist can pick up speed with less effort. Carbon wheels also cost many times more than metal ones, so your wallet will also be more lightweight. Flatter and thinner than metal ones, these high-tech carbon bike wheels are designed to take advantage of carbon fiber's unique characteristics and support the cyclist's weight efficiently. They start by cutting carbon fiber into patterns. These arcs are for half of a side wheel. The technician layers them onto a band of fiberglass in a mold. The fiberglass will provide a good braking surface. He drapes a piece of non-stick plastic film over the mold and adds a silicone pressure pad. He stacks several carbon-filled sidewall molds, each with a silicone pad and plastic film. He wraps a heater pad and a plastic vacuum bag around the stack and activates the vacuum. It sucks out the air to pull the melting carbon fiber to the shape of the molds. He adds an air bladder and metal plate. This applies more pressure as the carbon fiber solidifies into a sidewall shape. The next technician layers material for the wheel rims. He inserts strips of carbon fiber into a long and narrow mold, pushing it into the crevices with the Teflon wheel. He applies strips of carbon to the sides for reinforcement. He adds a resin-based film adhesive followed by more carbon fiber. Using a kind of wedge, he again puts on the pressure, causing the carbon fiber and film adhesive to stick together. He transfers the long layers to a round mold. As with the sidewalls, he heats the rims under pressure to set the shape. He'll get 5 wheel rims out of this one tool. The next technician shapes carbon fiber layers around a metal shaft and flares them out to form the wheel's hub flanges. She smooths the creases, then prepares for the vacuum pressure curing, placing a piece of non-stick plastic and a silicone mandrel assembly on top. She stacks the flanges and slides a tube around them. She bolts on a lid. Then it's into an oven to bake under pressure for about 4 hours. This transforms each patchwork of carbon fiber into a solid, seamless bike wheel flange. They'll now assemble the wheel. The technician inserts flat carbon fiber spokes into holes in one half of a sidewall. Adhesive and carbon fiber will bond the spokes to the sidewall. He places a carbon fiber patch where the end of the spoke meets the sidewall and tapes it there. With all the spokes in position, he lowers the lid and applies mechanical pressure. The spokes bond to the sidewall and it's ready for the rim. With the help of a locating pin, the technician positions the rim on the sidewall. He also uses this carbon fiber ring as an alignment tool. He places the other sidewall half with spokes attached on top. The geometry is precise for maximum strength and resilience. After another compressed bake, he applies adhesive to the ends of the spokes and attaches them to hub flanges. He places a metal spacer between the 2 flanges for now and tapes the spokes to prevent adhesive from trickling down onto them during the heating process. He adds a piece of release film and a silicone pressure pad. He clips metal splints to the carbon fiber spokes to support them through the cure. And with the spokes now pressure bonded to the flanges, it's time for fine-tuning. The technician locks the bike wheel in a fixture that stretches the spokes slightly. This creates the necessary tension and rigidity. Once he's satisfied with the tensioning, he applies resin adhesive through a hole in a hub flange. 2 hours in an oven sets the tensioning, and he removes the wheel from the fixture. After cleaning and the application of graphics, the carbon fiber bike wheel just needs a rubber tire, and it's ready to go for a spin.